So you'd like to learn about Firebase, right? Let me showcase to you the project that we'll be building in Firebase. This project will be in React, and as you can see, this is a little card library, each card having a power level, a type as of melee, ranged or siege, and a name as well along with an image. And these are all fetched from the database and the Firebase storage. If you're logged in, you will also be able to access an admin root, meaning you'll be able to add the new card, delete existing cards, and edit existing cards as well. We'll be uploading files to the database from our computer. For that, we'll be using Firebase's storage, and all the other data will be kept in the Firebase Firestore, meaning Firebase's database. I can also log out from here, and it will throw me to the login page. And the good thing about this is that if I'm not logged in and I try to access the admin panel, then it will throw me back to the login page. So we've also guarded our admin panel from unauthorized users. Of course, if you log in, you'll be greeted back and the data fetches, so you'll be able to edit the cards. With that, I hope you're excited about this, and let's get started. For this project, I'll be starting out completely from scratch, and I'll be creating a new project with Vite, typing in npm create Vite at latest, and make sure you're in a folder where you'd like to create your project. For video purposes, I'll be creating this on my desktop. Hit enter, and then you'll be able to name your project. I'll call this Firebase Crash Course. Hit enter again, and then choose React. Just the simple setup of a React project. I'll be using JavaScript only, there won't be TypeScript included in this one. And then run the top two commands, cd into the project folder and call npm install. Once that's finished, you can open up your project and we'll be starting from here. Another thing to keep in mind is that I have prepared some files for you in our GitHub repo. It will be down in the description below. If you come into the source folder, and then first of all into the assets, there are a bunch of images in the cards folder that we'll be using, but there is also a folder called copy paste files, and I advise you get all the files from here as we go through with the project setup, because there is a bunch of CSS files that you'll be needing, and there are also some basic JSX templates that we'll be using to speed up the process of building our components, because obviously I will assume that you can write these on your own. These are just basic HTML incorporated into React. And to start with this, I will grab our index.css file, come here to our index.css and just replace everything. I will be doing the same with the app.css, and I will also be adding the images, and we'll cut to the chase once you're done with that. Right. Now that we are done with that, I will be clearing up the app.jsx file. We don't need this, we don't need the logo or the use state right now, so I just delete those. I'll make the app.css linked, although it's completely empty, and I will delete whatever return statement we have over here. Leave an app div over there, because first thing that I'd like to do is fill this up with offline data. So I'd like to create a card component that will be laid out in our app, so in our main dashboard root. For that, create a components folder in our source folder, and I'll be creating a card.jsx file and then also a card.css file, and just get your own, paste it from the copy files that I've given you. And one thing to note here is that there is some logic already implemented in the card.jsx. So I haven't run the app yet. What we need to do is, because we are using React icons, is in a terminal, paste npm install React icons. Once that's done, we can start our app with npm run dev. Now let's start laying out data in our app.jsx. For that, I'll be creating a new use state hook called cards, and its pair will be set cards, and it will be a use state with an empty array set by default. And then instead of rendering a div over here, I'll give the class name card container, and we'll be mapping out the cards state over here, cards.map, then implement here the card and return some new component, and this will be of course the card component that we'll be importing up at the top. And as for its props, it will get the respective title, power, image and type, which for now is null because our array is empty. So let's create some dummy data over there. And what I've done over here is that I've implemented some objects into our array. these objects have an ID. This is hard coded in for now. Firebase will provide IDs for our objects. We have given some title and I've imported some images from our image folders. That's why it's important to have them locally as well. And then of course these just get mapped out. If you have a look, these are our two images laid out. Nothing too crazy. But this is what I wanted to do for the basic card layout and in our app. Next, we'll go on to creating the admin panel. We'll be laying the cards out like this there as well and working with offline data. But we'll be handling the creation of new cards, the deletion of new cards, the deletion of already existing cards, and the editing of already existing cards, all offline, and then we'll connect it with Firebase. Alright, let's come back to our file structure, and in our component, create an adminpanel.jsx file and also create its pair, which will be the adminpanel.css file. Of course, go into our repo and grab these files for yourself, for example, the admin panel, and then come to our app.css and below the card container, for now I'd like to render this there, put in a fragment and render the admin panel. And as I see, I've left in an error. This will probably be fixed when I upload the video. Just if you see any errors in these templates, make sure to resolve those. They are not complex, you just have to delete some data. And with that, below our current cards, there is add new card. This is going to be our admin panel and we'll be fetching cards over here. Just so we have something rendered over there, go back to our app.jsx and copy this cards use state. It's called the same in the admin panel, so it shouldn't cause any problems. And now let's work on handling the addition of new cards when the button is clicked and the form is submitted. Okay, so now let's go over what's actually implemented in this admin panel by default. As you see, first of all, the cards is implemented. This is the displayed cards that are listed down there. Then we have an isEditing state, which we won't be using yet. This will be to change the form. If it's editing, then there will be a cancel edit button and a save edit button. And as for the new card, this will always be the data that we get from the form, meaning whatever you input in here, that will be set to this new card. And then later on, we'll be handling the form submission, which is not yet created. So let's actually create a function and we'll be then chaining up the input fields and then handling the form submission. But to do that first, below our render icon, I'll create a new constant function. This will be an arrow function, handle add card, and this will be an async function later. So let's tag it with async before I forget that it will be an async function for Firebase's methods to work. And then just inside that, implement some functionalities. First of all, when you create a new card, obviously, you'd like it to have a new ID, and to not just hardcode that ID, we'll be calling for now the date.now function. This will return a number or a string that we can use to assign IDs to our cards. Next, we'll be having to create a new card, and this card will be the one that we add to the list of our cards. So const card, this will be a new object, and we are spreading the new card variables over here. So whatever is inside the new card, which will be dynamically set by our inputs, will be pasted over here. And since we've created a new ID, I'd like to add that ID to this card. After that, we call the setCards function and we spread the cards in them. So the already existing cards will be copied, and then we append a new card, which is the card that we've given over there. This is just some basic React, not really correlated to Firebase. And then I'll also reset the new card so that our input fields are cleared. For now, let's chain up the new card variables. And what I mean by that is that we search for our input fields and then set their value equal to the new card and the corresponding value, which for this one is going to be title, meaning whatever the value of whatever the title of the new card is, will be the value of this field. And also set up an onChange function, which receives the event object, and we return the set new card. And this new card is going to receive an object. We spread the already existing data into it with the new card being used, and then set its title to be the e.target.value. And this will be the schema that we'll be using on all of our input fields. So for example, copy this, and there is the next input field, which is for the power level. Paste it in, and the new card.power will be the one that we'll be setting. And then instead of setting the title, we'll be setting the power on change of this input field. As for the select, we'll be doing the same, but instead we'll be setting the type value. And also here, instead of setting the title, we'll be setting the type of the object. For our last input element, which will be the file, we will be emitting it for a minute. I'd like to test this functionality out with the submission, and then after that's working, we'll implement the image uploads. Here is a button, and inside this button, we are dynamically rendering some text. For example, if we are editing, we say save changes. Otherwise, we are going to put in a text and an icon called add card. Now, on click of this function, I will put in some conditional values. For example, if we are is editing, we'll call another function like console.log, and I'll just leave it like this for now with no actual parameters given. Otherwise, because this will be an edit function later on, otherwise we'll be calling the handle add card. I hope that's clear over here. And if you come back to our project, I'll get a bunch of errors saying that Geralt is not defined. Obviously, we have to import the images that I'm using in the dummy data. So copy these import statements up into here. And then instead of saying dot slash, we'll say dot slash. I believe that should fix it. There we go. And just so we know that this is working and we can test this out, let's console log out here the card, as if we are adding this new card to the cards. And let's go back to our app for testing. For now, I'll be choosing a card, but that doesn't really need to happen. Input some data in here and press add card. And as you see, Regis, or the card that I've uploaded, gets logged out and also gets rendered over there. Obviously, the image is not getting rendered yet, and that's completely fine because the image file property is null, as well as the image name, but we also have an ID with the date generated, and the others are exactly what I set up. Now let's handle the image upload functionality. Come back to our input field where we haven't put in any value or onChange event handlers. OnChange, I'll be calling something called handle image change. This function is not yet created, so copy this over and we'll be creating this up, let's say below the handle add card, const handle image change, and it will be just a function, but it will receive the event object. To grab the file that we've uploaded, working with these input elements is pretty simple. I'll create a new constant variable called file, and it will be the e.target.files. This is an array of files, and usually what you upload is the first image, and even if the user decides to upload multiple images, I will only get the first image out of this with the indexing of 0. And if the file exists, so he truly did upload something, then I'll call this set new card. This will be set to a new object. It will always spread the existing card values, and the image file will be set to the file that we've grabbed from the input field, and the image name, this will be the file.name. Let's see if this fixed our errors. Come back to our app and let's try this out. I'll add Regis once again. Kind of got fixed because we do have an image name and we do have an image file now, but until the very point where we start using this storage, we won't be able to upload the images over here because then we would be needing some helper functions and all that. But this is a Firebase crash course, meaning at one point we'll be having to upload images to Firebase, and then it has a functionality called get download URL, and I'll be able to then add the new card and get its download URL, and then as a source import it into the image. It's pretty simple like that. A few more adjustments that we need to make. I'd like to display the name of the image, and I'd also like to reset the input field once we've uploaded the file. And for that, I've spent quite some time on this. We'll have to force React to re-render the input component. I'll show you in a minute how to do that. A property in React that you can use to force an element to re-render is the key property. You can give a key to an input element, for example, like this file element, and then put a state in there, like I will call this file input key. Obviously, this is not yet created, so let's copy this over. And the thing is that this will be a use state, and whenever this gets updated, since it's a key to that element, React will force that element to re-render, meaning if we clear the values, like here we are setting it to null, and we're also setting it to null after we've added the file, and it's still not causing re-render, then we can actually create that use state and then simply change the use state value. It doesn't really need to be anything. It can be a Boolean value, a number or whatever you'd like it to be. So const, put in the name and then set file input key, and this will be a use state with for example 0. And after we've handled the handle@card, after we've reset the image file and all the other values to null, I'll call the set file input key, and then I'll set it to the file input key +1. Let's test this out once again. This time I'll choose a different character. I'll press add card and our image is also getting displayed over there. Everything is working, and we've also reset the file, which is exactly what I wanted to do. Next we move on to deleting a card from here, and then the editing. Then we can actually get started with Firebase. Okay, let's come back to our project, and below our handle@card, I'll create a new function just like the handle@card, but this will be handle delete card. It will be an async arrow function, and for this function we have to know which card to delete, so it will receive an ID as a parameter. The logic for this is going to be extremely simple. As long as we are not using Firebase, create a new array. This will be the updated cards, and it will be equal to the cards.filter. And using the filter function, I'm interested in all the cards where the ID is not equal to the ID that's given over here. So the ID that I like to delete. And after that, I'll just call the setCards function and pass in the updated cards. Now all we have to do is find the button called with the delete icon class, and using the onClick event, we'll pass in an arrow function, and we'll call the handle delete card with the card.id, where the card is the current iteration since we're mapping the cards out. Let's test this out. Let's say I want to delete Geralt from here, and he disappears. No errors given in the console, so that's great. The delete functionality is done. Let's move on to the editing. For this, we'll be doing the same, create a new function, but this time we'll be having separate functions. The first one is going to be handle edit card, meaning we've clicked on the edit button. It will receive a card as a parameter, and all this is going to do is set isEditing to be true because we've started the editing process. Also call the set new card because I'd like everything to be the same in the new card except the image file, so that if we started editing, I'd like to reset the image file that's currently chosen completely. So spread the new card over here and set the image file to be null. And as I said, this is not enough, this won't re-render the UI, so I also call the set file input key. This will be the file input key +1. We will not implement this yet, we'll create the pair of this, and this will be the const handle save edit. This one will be an async arrow function because later when we're working with Firebase, it will be important that this is async. And inside this, all I'm going to do is create a new constant variable called updated cards. This will be equal to the cards.map. So we're going over all the cards that we currently have. This will also receive the card just like any map function would. And this will return if the card.id is equal to the new card.id, the new card being the one that we are currently editing, then we'll render the new card. Otherwise, or return the new card, meaning the array will get updated. Otherwise, we'll return the already existing card, the one that we haven't touched. And we'll call the setCards function, which will update the cards. So we set the updated cards to be the set cards. And after that, I'll just copy paste this in because this is now repeating ourselves. We set isEditing to be false. We reset the new card and we reset the input if any file was updated. Of course, during this editing, we are not handling the file uploads, and that's completely fine because we'll be needing the storage to handle that. And one last functionality that I'd like to do is the handle cancel edit. This will be another arrow function. We'll set the isEditing to be false and basically just copy this from over here. We reset the new card and set the file input key to back again, meaning we clear whatever file we've selected during the editing process. And with that, we are done. This will only work locally, but let's implement this. As you see, if you search for isEditing, there is a button called cancel edit that will only appear when we are editing. For this, I call the onClick function and pass in the handle cancel edit. We've also implemented a console.log over here if we are editing and we click the save button. So instead, I call the handle save edit and also search for the edit button. And on click, if we are to click this button, pass in an arrow function which we'll call the handle edit card, meaning it will start the editing process, and there will be the card pass in, which is the current iteration when we are mapping out the cards. It's all that simple. Let's see if any errors occur. So far so good. Later on, what I like to do is populate the fields, for example, with the name. Let's see if I can change this to be simply Geralt and a temp power level, maybe a siege type. Let's just choose an image, but this won't be functional, and then save the changes. And of course, it doesn't do anything because we haven't implemented any logic for changing the actual card data. The only problem we have with this functionality is that I'm spreading the new card over here, and instead we are not using the card, so we should be spreading the card instead of the new card, and this should copy over the ID of the card that we've clicked on, meaning we now know which card to edit, and this should solve the issues we've been facing before. So let's click on editing Geralt. Now the fields get populated, and we change this to be simply Geralt, change the power level like 14 and save the changes, and the change appears. It's exactly how we planned it to be. We obviously cannot change the image, but that will be something for later. Next, we'll be implementing Firebase and the data uploads to Firebase. Now to implement Firebase, go to firebase.google.com and you'll be greeted by this over here, this website. For this, obviously, you'll be needing to have a Google account, which I'll assume you have. And then you can go to the console over here in the top right edge. And as you see, I already have some Firebase projects set up. This is the dashboard of the Firebase crash course when I was developing the app, but now we'll be going through this together and click on creating a new project. I'll be calling this Firebase Crash 2. For this, you can either enable or disable Google Analytics. I don't really care about this, so let's just click continue, and then you'll be having to select an account. You can, if you don't have one, you can create a new account, or I'll be selecting the default account for Firebase and then click create project. Once the app has been set up, it will take some time, of course. Then you'll be greeted by this dashboard, and we'll be going over how to use this dashboard, but this will be step by step. And the first step is to decide where do you want to incorporate this Firebase project. There is an icon for the web, so click that. You have to give your web app a name. It will be Firebase Crash 2 for me. We don't need Firebase hosting because, or at least I wouldn't want to deploy it with Firebase hosting. I'll be deploying it with either Vercel or Netlify. I will register the app, and then if you're using NPM, here are a bunch of options, and we are using NPM. Otherwise, you can go to using a script tag, which I don't really recommend. We'll copy this into our terminal, and we'll later be needing to create a file to incorporate all of this over here. Now, if you're worried about the API key, you do not really have to worry about that because we'll be implementing security measures to our Firebase database. These are meant to be public. Otherwise, outsiders wouldn't be able to use your app. Now in our file structure, let me just close all of these up. Inside the source folder, we'll be creating another folder called config. And inside that, we'll be creating a new JS file called firebase.js. Also, while we're at it, I will stop the development server and paste in the npm install Firebase, hit enter, and this should install the packages for us. In the meanwhile, go back to your setup and copy this code we've already done with the terminal over here. Paste in whatever that is given to you. It may change over time, but it generally doesn't. And as for the analytics, as you see, there is something called an analytics over here. I'll just delete that. Also the import statement. Now let's go over what this file actually is. This is your Firebase config file. It contains important information about your app so that it can be recognized by Firebase. First of all, you have your API key, then out domain, project ID. These are all needed to identify parts of the Firebase project that we are incorporating. And there is also an initialize app function pulled in from the Firebase/app. This app will be needed to a lot of things. This initializes your Firebase app at runtime because this script will run when you run your app. Later on, we'll be pulling in the database, and this app will be needed to given as a parameter to those objects. And those objects will then later can be pulled into our scripts, and then they'll know what app they are linked to, and they can upload to that certain app's database. That's basically it. You don't have to worry about any of this. These are unique to your own project and it shouldn't be changed unless you really know what you're doing. But that's basically it for this file. Now I'll run the development server once again and hide this terminal. Come back to Firebase and click continue to console. Now we'll start to get a little familiar with the UI. As you see, there isn't much over here. You can choose to add the product to your app, which can be either of these or under the build. There are a bunch of functionalities that you can add to your project. There are 3 that we'll be using here, which will be authentication, the cloud Firestore, and the storage. As for the authentication and the storage, we'll be adding them later. And as for the cloud Firestore, we'll be adding it now. Cloud Firestore is basically the database of Firebase. Click on this. And Firebase is a NoSQL database, meaning it works with documents and not tables, if you know what that means. But you'll see it in a minute, because once we create this database, we'll be adding records to this or documents to this by hand, and you can choose which place you'd like your data to be kept. I'll go with the default with the United States. After you set this location, you cannot change it later, so be wary of this, and then click next. And over here, this setup is very important. These are the security rules for your database so that other people can't access your database, because your API key is public and it's meant to be public. They can find your project, but if the security rules are set properly, they won't be able to enter anything into your database. And with this, allow read write if false, we are locking ourselves out of the database as well. So it's always important to start in test mode. What this says is that allow read write if, and this gives you 30 days of time, and you can later change this to be, I don't know how much would you like to work on the project in the test mode, but probably 1 month will be enough. So until that 1 month expires, you will be able to edit your database. Let's hit create. And there we are. We are greeted with this collections tab, and we have a bunch of other tabs as well. Let's go over what we have in these tabs. For example, we have the data at first. The way the data is set up at Firebase is that there are collections. You can have multiple collections, and then inside the collections, there are documents, and you can obviously sort them in a more complex way if you want them. But for example, let's create a collection, and each collection has an ID. This one will be, for example, cards, because that's really one that we'll be using, but we'll be automatically generating it from code. So let's add this. This will be the identifier, or this will be the name, and then the identifier will be an auto ID, which Firebase generates for us, and we can add in fields from here, but I'd like this to be nothing. I don't want any fields in it, because we'll be creating that with our hands as well. As you see, it's getting populated, and well, I said I don't want any fields in this, but it already created a field or a document for me. We'll be ignoring this. Let's add the document for ourselves. I'll auto-generate its ID. Its field, for example, will be name, or better yet, title. It will be of type string, but you can choose other type of strings over here. The main ones are at the top, which is string, number, boolean. And as for the value, I can just say Geralt of Rivia. I save this, and it has a title called Geralt of Rivia. And these documents can have multiple fields. They also store JavaScript objects, meaning they can convert it. If you send it a JavaScript object, when we'll be doing that, then it will convert it, get the keys out of it, for example, title, ID, image name, whatever we have in our dummy data, and it will get uploaded. So that's a brief overview. You'll be getting into it more. And then let's go to the next tab, which is our rules. These are to guard our data. As you can see, you can change over here for how much you'd like to access the database. I won't be messing around with this now. There are also indexes. If you have a query, which I might include at the end of this video as an extra, then you can index your elements so that querying is faster. This is a new feature. I haven't met this one yet, the disaster recovery. I don't think we have to worry about it that much. You can back up your database, and there is a usage tab, because as for the free tier, Firebase has quite a generous amount of calls, writes, and deletes for this database, and it's, unless you have an infinite loop, it's quite tough to go overboard. So if you're coding along with me, we'll put extra emphasis on not creating infinite loops because in the real world it will cost you money if you cause infinite loops, and if you start calling the database over and over and over again and essentially run out of your quota. There are also extensions which we won't be exploring, but basically we'll be spending most of our time in the data section. That's it for the UI of Cloud Firestore. Alright, so continuing on, what I'd like to do now is delete this whole collection that we've created over here because I won't be needing it. As I said, we'll be creating this from code. So pass in the cards or the name that it wants you to delete and then click delete. The next thing that we are going to do is set up our database so that it's exported from our config file. How we are going to do that is create down below our app a new constant variable called db as of database, and it will be the get firestore. Import this function from Firebase, and as I said, the app is needed to identify which functionality needs to be linked to that, so we pass in the app, and then we have the database now, which later we'll be accessing to upload the data. But we can't access the database because we are not yet exporting it. So I'll export an object over here, which will have the database included. We'll expand on this with the authentication storage, but for now, that's it. Let's move back to our admin panel, and we'll be working mainly in the handle add card. As you see, we are creating an ID with the date.now, but I'd like to use what Firebase does for us when we create a new document. And for that, we'll be needing to implement a little trick. But let's first of all talk about how to upload files to the Firestore database. First of all, when you're trying to upload a file or access anything, you need to have a collection. And what the collection is curious about is which database you are going to access, and then what is the name of the collection. Once you have the collection, you can then get a reference, which is a document reference, and is going to be interested in what collection are you trying to access and is there a given path to it. And this one is optional because if there is no given path for the document reference, because for example you'll be adding it later, just like the trick that we are going to be using, then it will just create an empty reference in your database. And then there will be functions for manipulating the database, and they will be interested in a reference. So for example, where do you want to upload it? And the data will also be interesting for them. That's a little cheat sheet that you can have a look at. So let's start implementing this. Let's go up to our file because there is something, as I said, the collection, which we'll be using repeatedly. And I don't want to always write this out. So I will create a new constant variable called cards collection because I will be calling my collection cards. And then there is a function from Firebase that will get auto-imported. Auto-imported if you call the collection function. And then inside that, as I said, which is it interested in? It's interested in the database. If I click the database now, it will import it from our config file because I called it db. There you can see it. So it's interested in which database are you going to search for the collection, or if it's not existing yet, it will create it. Then the second, as we said, is what is the name of this collection? Well, the name of the collection will be called cards. That's pretty simple so far. Now let's jump back to the handle add card function, and the way to upload a card is by either the add doc function, which we won't be using this time, or with the set doc function, because if a document reference already exists, you can reset it, set the document to be something else. And we will be using this to update our database as well with the edit functionality. As the sequence goes, now we need the reference. So I create a constant variable called docref as of document reference. And there is a function called doc, which you can import from Firebase. And this doc, as I said over here, is looking for a collection. What collection should this reference be created in? Where the collection will be the cards collection. And then there is a path that you can give. Later on, we'll be adding a path here, but not for now. All this does now is create a document reference, an empty document reference that has an ID in its name. And that's perfect for us because then I can delete this damn ID from here because I don't want it, and then get the ID from the reference. And for that I'll be creating a new constant variable called new card with ID, and it will be a simple object that spreads whatever we have in the new card. And as for its ID, I'll overwrite it with the docref.id because it has an ID field. For now, I'll delete the console log and the const card as well. And actually, let's delete the set cards as well for now. I want to start this all over again from scratch. The set new card and set file input key can stay because these are the things that we handle when we after we finished adding a new file. I'll cut those and incorporate this into a try catch block. I'll paste these into the try catch block. These will be at the end of the try. Later on, we'll be implementing the storage uploads over here as well. So I'll create an image URL, which will be set to be an empty string. And we'll be adding a new key to this element with the new card.id.image. This will be equal to the image URL. You can simply ignore this step for now. And how, as I said, you upload a file is by calling a function for manipulating the database, which is the setDoc function is what we are going to use by default. And this returns a promise. This is an async functionality, so we have to await it. I don't want to move on with the code until we've got back the data or this functionality finished. And what these functions receive, if you come back here, is that they need a reference. Now, lucky for us, we've already created the reference. So Firebase will know that this is the card that we are talking about. This is the one that we'd like to modify. And then as for the second parameter, we pass in the data. As you see, it can be anything. And as I said, we can pass in JavaScript objects because Firebase will accept those objects. Now I'll do this and then we await the setDoc. And then after this is done, I simply reset all of this here. If something goes wrong, I'll just console log out an error adding card to Firestore and then the error. Let's try this out. Oh yes, and what I've deleted from over here is the set cards. So we are setting the cards to be the same as before, except we are adding the new card with ID. Pretty simple. Now let's try this out. And I get an error because get Firestore is not defined in our Firestore script. So let's come back because it didn't auto import. So import get Firestore. Now this should be working, I believe. And of course the ID just stopped working because then I have to import all the other functionalities as well, like the collection and setDoc. So let's do that. Import the collection. In the same line, import the document. And did we use anything else? I don't believe so. The setDoc is imported. And there we go. No more errors in the console. So I can add the new card, let's say 8, it will be arranged. And now I can add this and it says type does not match the expected instance. Did you pass a reference from a different Firestore SDK? What I did wrong was probably the auto import imported this from Firebase/Lite, which I don't really want to do. So instead I'll import next to the collection and the doc from Firestore. Let's see if this works now. Yes, it does. I can add the card. And let me show you what we didn't handle yet. So for example, if I try to add another card and I choose an image, for example, Tris, and add it, we get an error saying that it was called with invalid data. And that makes sense since the file type or the file that we are storing in our data is actually of type file. And the database is not meant to store that. It's mainly meant to store a few bytes of data, not whole files or like images. That's what the store is for. So to fix that, and first of all, let's go back to our database and see that it actually worked, and then we'll fix this error. As you see, there is an auto-generated ID. It has the ID. As for the image and the image file, those are null. All the data that I've inserted got uploaded there, so that's perfect for us. But what's causing this issue now is that there is a property called image file. And if I choose a file, then it's not null and it can't handle that. So what I'll do before we enter the try catch block is call delete. This delete keyword will delete a key from a JavaScript object. And that's exactly what we want to do with the new card with ID dot image file, because I don't want to upload the image file. Now this should be working. I won't be testing it now. We'll test it later. But next, let's work on fetching the data from the database. and then we can start working on finishing the add functionality. But I'd like to work with data that's now already fetched from the database instead of displaying dummy data. So above our handle add card, I will create a new constant function. This will be obviously an arrow function. It will be called fetch cards, and it will be an async function. It won't be passed in anything. What we do inside this is that there is something called a getDocs function. But if you have a look at the documentation, this getDocs function returns multiple documents, and it will receive as a parameter something called a query. A query just stands for get multiple documents from the database, and then we can also define, for example, just like you would in an SQL database, a limit, an order, or which data should be fetched, but maybe that I'll add as an extra at the end of the video. For now, just create a constant variable called Q, and it will be the query function from the Firestore. And as for the first parameter, it will receive a collection. Where do you want to query? Where do you want me to search? And we'll pass in the cards collection. The second would be the filters of which data should I get from there, but we'll omit that for now. And then incorporate a try-catch block. We'll create a new constant variable called cards snapshot, because when you're getting multiple data from the database, it's usually going to be with the getDocs function, getDocs as of plural. It will throw you back a snapshot of the database, which you can go through, and it will contain the data. This getDocs functionality receives a query. That's why we needed to create that. That's the order. You get a query, then you call it the getDocs function, which then throws you back a snapshot, and then you go over the snapshot to extract your data. So I pass in a Q as of the query. Now we have to get the data out into a variable, which I'll call temp as of temporary variable, and it will be the snapshot.docs. This is built in, and we are mapping those docs as of we are looping over them. Each will be called a document, and I'd like to extract this data now. And I'll extract it as a JavaScript object, and I'll say the ID should be the doc.id. This is a built-in field. The auto-generated ID is what I'd like to get from there. And let's wrap this in parentheses like this, so we don't get any errors. And then I'd like to get the rest of the data as well for each document we are going over. So I call doc.data. If you were to console log out the doc.data, what you would get is basically the JavaScript object that gets fetched from the database. So this is something that you, when you're working with Firebase, have to know quite a bit. I mean the order specifically. You get a query, and then you get back a snapshot from the function that you pass in the query to, and then you have to loop over that snapshot to get the data. And the reason I call this temp, because this will go away. All I'm doing here is now setting the cards to be the temp. If we get an error, I will console log out that error. That's all we're doing here. And when you are fetching from database, that needs to be in a useState hook, and pay very close attention here. I don't want you to run into an infinite loop. We pass in whatever needs to be executed. And before we do anything, pass in here a dependency array, because this will prevent you from having an infinite loop and flooding your database with calls. And now we can call the fetchCards function over here. If you refresh now, we still have the dummy data incorporated, so you'll see Geralt over there, but then it got replaced with our imageless card that I've uploaded. And that's great, because that means the fetching from the database actually works. So we can also delete the dummy data that we have right now. Open up the cards and just delete these two objects from here. It will be an empty array by default. I hope what we were doing here is understandable. We've learned how to fetch multiple data, but we'll be doing this once again in the app where we are displaying all the cards. For now, let's leave it for later. And when we add the doc, we can call the add document, which will just only add the document, but the set document will also create the document if it does not exist. And we'll be using this to also overwrite some other documents. And the sequence is very important. You get a reference with a collection, and then you pass it into the function with the data that you'd like. This is usually how this goes down. Let's jump to setting up our storage now. Come back to your Firestore dashboard, and then below build, you can search for storage. Now, Firebase implemented a new policy that you need to be on the Blaze plan, meaning it's not the free Spark plan, but it's actually free. You just need to link your credit card. Now, this is where most of you will quit, saying, well, I thought this was completely free. And in fact, it is. It's still a very generous offer for Firebase to provide this. And unfortunately, this is something that they've implemented. But if you don't go overboard with your data in the storage, which is 5 gigabytes, and I don't believe you'll be uploading 5 gigabytes of data in a small or medium scaled app, then you shouldn't be worrying. And even then, you won't be charged only if you activate a fully priced plan. Go over this with me, update your project, and then you won't be having a billing account. You'll have to get yourself one. I'll also just select my already created billing account. You can set a threshold so you'll get notified when the billing starts to get a little too much. So for example, I set this to 1, meaning if my database storage is too much, then, and I've already spent $1 on this, then notify me. And when this notifies me, I will of course by hand manually shut down the storage or clear the data or whatever. So let's just click continue over here. It will be the pay-as-you-go plan, but this of course means that it has a free plan, a free version. And link cloud billing account. Click done and basically you're done. You can now get started with the storage. So if you were still watching and you did this, then good job, it didn't scare you away. Now let's continue on. Get started. Here you will be asked to select a server. These will be the no-cost locations. This is what I recommend you use. And basically I just go with the US Central. I click continue and start in test mode. This is the same. It also has rules as the other database had. Nothing you have to worry about. We'll be going over this and then just hit create. And there you go. You have now a storage where you can upload your files. The other two are basically the same. What you have to keep in mind is that you can upload files here by default, or you can create new folder and have this structured into folders, and we'll be doing that. If you click on upload file, I can upload any of these files here, but I won't be doing this by hand. You can play around with it. We'll be doing this all from code. So now come back to your Firebase configuration and below database, create a new constant variable called storage, and it will be the get storage. I hope this imports it now, but no, it did not. Great. So I will import the get storage. There we go. You call this function and you pass in the app. It's that simple. Now I also export the storage and then we'll be able to upload our files to the storage now. Now let's finish our creation functionality by uploading to the database. What we've missed here is that the image URL is not actually set. And this is the place where we should be uploading our files. For that to happen, I'll create here an if statement. If new card.image file, meaning if we selected an image to upload, then this is what we'll be doing. We'll be creating a constant variable called imageref. As I said, these functions usually take in a reference, and for the storage as well, this rule stands. So I have to call the ref function, import this from the storage, and once that's imported, I can call this function. In here, you have to pass in the storage. The storage will get imported from our config file as of which storage you want to upload to, because there can be multiple storages in a fully complex app. For now, we'll be using one, and the free plan also only allows one storage. And then you specify a path where you want to store your images or files or whatever you upload, in our case images. For that, we'll be creating a new folder in there called cards, and then slash. And then with the template syntax, I pass in there the new card.id. It's important that I fetch from the database first before we handle this upload functionality, because now the ID is set from the database because the card is fetched, and this is not new card but a new card with id.id, and then I put in again a slash, so I want to store images inside cards, and then slash the ID, that will be another folder, and then inside that I store the actual card, which will be the new card.image name. So I'm storing it by the name. After this, we have our reference. We don't have to await the reference because it will create it with the upload. And now we have to await the function. This function that we are going to await is going to be the upload bytes, meaning we are uploading bytes to our storage like an image. And this will receive the image ref because it wants to know where to upload that image. Well, that is the path. The image ref is where you should upload and what name you should upload it with. And then you pass in the file, which will be the new card.image file. It's that simple. With this, you've uploaded to the database, but that's not enough. I still want on the client side to get the newly uploaded image, and to get the newly uploaded image, I have to set the image URL because we've already defined it, image URL, there we go, to be something from the storage. And the storage generates download URLs for the uploaded images, meaning the URL which if you pass into the browser, it will link to the Firebase storage and then the image is basically visible there, but we'll have a look at this. So await, and what you're looking for is get download URL. This is also from the Firebase storage. I hope it's auto imported. We'll check back above. And then you pass in a reference to which you'd like to get the download URL. Luckily, we have that reference. So we can set the URL to be just that. And after we finish with the uploading and get our URL, the new card with id.image will be called the image URL. The one thing I'd like to check is if we are setting the image or referencing the image property, if we are fetching from the database, and yes, we are. Here in this style, we are referencing the background image to be a URL with the card.image. Let's test this out and see if I've missed anything and run into any errors. But before we do that, I'd like to delete Jennifer from here because she doesn't have an image. So actually I create the whole collection because that's easier and it will always be created again if it doesn't exist. Have a look at our storage as well. This is empty. That's great for us. Let's see. I refresh and add the new card like Gaunter or dim. He will be of type siege. He will have like 6 power, and choose Gaunter from here. And now I can probably add this card. And without worries, it did add the card. As you see, it already fetched from the client side, which is very great for us. And I can look at our storage, and there we go. It has the ID inside the cards. And it has the gaunter.jpg, and the download URL for this one is this gaunter.jpg. If you open it up, this is the download URL that we are fetching. Now let's come back to our storage because I feel like I forgot something, but maybe that's not true. Let's check on the record that was created here. It has image name, power, title, type. It has the image. Well, it seems completely fine to me, so there are no worries about this. With this, we are done with the upload functionality. We can now work on deleting from the database, and we can also work on the editing functionality. Now let's finish the card deletion and deleting the images from our storage, and also deleting data from our database. Let's clear what we have for now and start from scratch. I'll be implementing a try catch block, where in the catch I console log out the error. And then what should we do in the try block? We should do 3 things. We should clear what we have locally, clear the database, and clear the storage. Let's start with deleting the document first. There is something called, and I'll await this, delete doc. This delete doc function will get a reference, and then the card at that reference will get deleted. To create a reference, you call the doc function, which creates a document reference. You pass in a collection, just like we did before, but this time we are going to provide a path to it, and that path is actually going to be the ID, because remember we are passing in the ID that we'd like to delete, and in our storage, actually let me show this to you, the path is going to be the cards, which is the collection, and then slash, which is already known when you call the function, and it's searching for a name like this, the ID, and we've passed in that ID from the fetched files. So that's good for one. We can delete this card, and next we have to delete from the storage. So we also need a reference here, and for this I'm going to create a variable called folder ref, and it will be the ref as we used before. We pass in which storage are we looking at, because we can have multiple ones if you are paying for it, and we are looking for the cards slash, and then how did we do it? Remember, we passed in the ID as the second folder. So again, I'll just simply pass in the ID. But now what if during the editing process, or for whatever reason, there are multiple images that are uploaded there? Then I'd like to delete all of them. In fact, I recursively like to delete all of the images that are inside that folder, and then that folder. To do that, I create a new variable called folder contents, and it will be the list all function. But this is an async function, and it will receive a folder ref, so I have to await it. And the reason it's going to await a folder ref is because this is going to list all the objects that are inside the folder. That's why it's called list all. And now this is going to throw us back multiple promises. And if you're not familiar with how to handle multiple promises, this might be new to you. Otherwise, it can be pretty familiar and quite easy. I store those promises in a constant variable yet again called delete promises, and it will be the folder contents.map, or sorry, not folder contents.items.map. It will receive the item reference, and it will throw back the delete object, which is yet again how you delete an object from the storage. This is a new function. Then delete object is how you delete one. And then it will receive a reference. And luckily we have a bunch of references from the folder contents because it gives us back references to all the items, which we then loop over and then delete them manually. But this doesn't resolve. It just throws us back the promise. And to make this fast, that's why I chose to resolve them at once. We'll call the await promise.all and then pass in the delete promises, meaning we will delete them all at once. We first just collect what we want to delete, promises, and then we execute them all at once. So it's not one by one, which can be quite slow. After that's done, the third part comes where we update the local data, and it's going to be rather simple. Const updated cards. Maybe I shouldn't have deleted all of them because we are just going to repeat ourselves, but that's fine. It will be cards.filter, and then we are looking for all the cards where the card.id is not equal to the ID. After this, we set the cards to be the updated cards. That's all. This should handle deleting our cards from the storage. If I refresh, so far so good, we don't get any errors. And then I can click on the little trash icon as to delete, and then wait until it finishes and it deletes it. I could also console log it out for debugging purposes, but we have the Firestore over here, so I can just refresh and we will see that there is the cards collection, but it's completely empty. If we come to the storage, our storage is also completely empty because we've deleted all the files and even the folder, so there is no point in storing an empty folder. That's why Firebase deleted that also. We'll be moving on to the editing functionality next. Okay, let's start working on the edit functionality. For this, we'll be working only in the handle edit save function. We'll be leaving the local functionality like this for now. I mean, handling the local rendering. And instead what we'll be doing is creating a new constant variable called card data to upload, and it will be set to the new card. We instantiate this new card data to upload so that we can play around with this. And next we'll be handling all of this editing in a try catch function. If something went wrong, we'll catch it in the catch function and console log it out. In the try block, what we have to do first to update a card is get a reference to that card, which is it in the database that we'd like to update. So const card.doc.ref, and we'll say await with the getDoc functionality. And how do you get a reference to an object from Firebase? As we did before, we pass in the cards collection to the doc functionality and then pass in a path, which is the new card.id in this instance. Next, I'd like to get its data. So for example, const edited doc data, and this will be set to something that we await. What could possibly come in here? Well, I'd like to get the data of only one document. For that, if you start searching on your own, you'll find something called getDoc, as of getDocument, and this receives a reference. This reference is of course going to be the card.doc.ref, and that's not enough for us. As I said, I want to get its data, and we've already called this function once. We are going to do it again. This will be the data function. This returns back a snapshot and it has the data. Now before we start touching into the storage, I'll delete the card data to upload.image file because we cannot upload that to the database, as I've covered this before. And what we're essentially doing is awaiting the setDoc function because we are setting the document and we are setting the card docref as the first parameter. And then what are we setting it to? Well, basically the card data to upload holds our data that we'd like to update the reference to. And then there is a third option, and this is an object of options basically. And here's something called a merge. Merge means, should I keep the existing data and merge it with the new data so that the new data gets only implemented and the new data then overrides the already existing changes? And that's right, I'd like you to do that. So we'll set this to true, because then if we don't change other data, then only those that we changed will get overwritten in the database. The rest can stay like this. But with this implementation, we are not handling the image files. And for that, we'll be creating an if statement. So if new card.image file, meaning do we have an image file at all? If yes, then we enter this, but we have another condition, and the sequence here is important because first we check if it's null, and then if it's not null, we also check if the new card.image file.name is not equal to the edited doc data .image name, because if we have the data up there and we are trying to upload the same image by name, it's not a fully fledged out check, it's just a little bit of security measure that if I want to upload an image with the same name, then we won't let the user upload that. It would be way more complex if I wanted to check if we are actually uploading the same image, and this is what I found that will suit this tutorial the best. So if these two conditions are true, then I set the card data to upload.image name to be the new card.image file.name. And now we have to update our data. As before, I create a reference for the storage, and this reference is going to be called image ref. It will call the ref function from the storage, and we pass in which storage are we looking at, just as before, and then pass in the path, which will be cards / and then card data to upload.id, and then / which image am I looking for? Well, I'm looking for the card data to upload.image name. With that, we have a reference, and now we can safely just upload to the database. So if this takes into consideration that this is a new image that's not yet uploaded to the database, we simply upload it using the image ref and the new card.image file. And of course, we need to update the UI as well. So just as we did before, the card data to upload.image will be updated. It will be the await get download URL. And we are getting it from the image ref. We've done this before. This is just repeating ourselves, a little bit of practice. It doesn't hurt. So with this, our edit functionality should be working. Let's check this out. Actually, we have to add some new cards. There we go. I've added some new files. Let's see if we get any errors from Firebase. For example, I'd like to update Jennifer and change her power level to be 10. I save the changes. And it actually got saved. Let's check in the database. There we go. This is Jennifer and this is her power level. It actually got updated. That's good. Now let's change the image. For example, I'd like Geralt to be Geralt of Rivia instead. His power level to be 15, and choose a different file. For example, this other variation of Geralt, and save the changes. It's getting processed. Our image is there. Let's see the database first of all. There we go. Geralt's data is updated, and let's check in the storage cards. There are multiple data now, and now we have two variants of Geralt's images there. This is something that I wanted to implement like this. You can play around with it. Maybe you'd like to implement it somehow else, but basically there we have both images. With this, the edit functionality is done. And that's really good news for us because I can move on to fetching the actual cards from the database in the dashboard, and then we can move on to routing, the login form, authentication, and root guarding. So before we do anything else, let's fetch the data. I'll find the fetching functionality, which is over here. And in our app.jsx, we should be able to use this functionality. So I'll remove the dummy data and use the fetch cards. Most of these won't be defined, and I will remove the imports from here and import instead the use effect. What else we didn't import? We didn't import the query function. We didn't import the cards collection either. So call the collection. Neither did we import the get docs. We also need to import the database. Let's see, what else did we miss? And there we have it. It's now fetching as we expected to. Now let's move on to routing. For this, I'll stop the current development server and we'll be using React Router DOM. I've made a whole video on it. If you're not familiar, you should watch that if you want more in-depth knowledge. Otherwise, just follow along with me. React Router DOM, npm install React Router DOM. Wait for this to finish and then we'll start. I'll run back the development server again and come back to our main.jsx. This is where we'll be starting. You could also look up the documentation, or you can just copy these over or type these out. We are importing the create browser router and the router provider. And this is the router we'll be using. So we're defining a user with the create browser routes. What we're saying here is that if you are at, for example, localhost or whatever your website is by default, you render the app component. I'll just copy this over. This out route is something we'll be creating later, so let me remove it. The /admin will open up the admin panel for you, and then the login is something that we'll be creating later, so I'll comment this out. And now all we have to do is call the router provider as an element over here. And then as for its router parameter, I pass in the router. Also, while we're at it, at the app.jsx, I will remove the admin panel and the wrapping fragments. Let's see what this does for us. Admin panel is not defined somewhere. So in the main.jsx, I should include the admin panel. And there we have it. This is our basic dashboard. We're just displaying the cards. Let's go to /admin. And now I can go to /admin. The logout button is not yet functional, of course, but it fetches just as it should. And you already see the problem. We are not authorized, yet we can access the admin panel. This is not good because you don't want simple users to access the admin panel that you create for yourself or for someone who has access to it. That's why we'll be creating a login form. Inside our components folder, let's create a component called loginform.jsx. And I've actually provided this to you in the copy files, as well as loginform.css. So let's implement this. And now if you come to the main.jsx and uncomment this one, the login form actually takes in a function called onLogin, and it will be passed in the handle login, but for now we won't be passing in anything. Instead, import the component. And if you visit the /login page, you should be able to see this. There are some errors we're getting that some future elements will be changing at React Router DOM, but that's okay, just ignore those. And now let's move on to our Firebase console and set up authentication. How are we going to set up authentication? Well, if you come to the build, there is a tab called authentication, and you can click get started, just as we did with the storage. And then you have to get started with the provider. Here are all the providers you can manage logins with. But for now, I'll be simply going with the email/password. I'll enable the email/password, but I don't enable the email link. I don't need that. And I can click save. You can always add a new provider over here. As for the users, we won't be implementing a register functionality in this app. But instead, what I'll be doing is adding a user by hand over here, test@gmail.com, and then provide a password to it, like this dummy password, and then add as a user. Now it's at a user, this will be our admin user. What's the next step when you implement a functionality like this in your console? The next step is to implement it in your configuration as well. So const out will be the get out from Firebase, and then pass in the app. Did it import it? No, of course it didn't. Get out, there we go. And we can pass in the out to the export. Now, as for this parameter that gets filled over here, this is a mistake by me. I didn't mean to actually implement this. It was just a leftover from the code where I was developing. Instead, we'll be defining a new function here, const handle login. And this will be an async arrow function. Since it's going to be on a form submission, I'll call e.preventDefault, and it will receive, of course, the event object as e. Before we do anything with the login, I'll call setError and set it to be a null. Then we'll implement a try-catch block. If we got an error, we console log it out and set the error to fail to login. Otherwise, in the try block, I'll await a new function called sign in with email and password. As you see, if you search for sign in, you get a bunch of options. These are because all of those providers are provided with Firebase, and I can simply pass in the auth as the object from our config, the email, and the password. That's simple. And while we're at it, I can also redirect if we log in. For example, there is something we can import from React Router DOM called use navigate. I'll import this, and below, when we define the error, let navigate will be equal to the use navigate. And after we successfully signed in, what I can do is navigate. So I can return navigate and to the /admin. This way we are redirecting the user or ourselves, basically if you are the admin, ourselves to the admin panel after we've successfully logged in. But that's not enough because we are not calling the handle login function anywhere. So to do that, we'll come to the form, and on submit, we'll call the handle login like this. Let's see if we can successfully log in. We can, because we then get redirected to the admin panel. And we don't get any errors in the meanwhile. But I can yet again come back to the login page, and that's not good for me, because why would I log in again if I'm already logged in? Another thing is that I can reach the admin panel without actually being logged in, but I won't be able to test this because right now my session is logged in, and unless I clear the cache of the browser, Firebase will remember that I am logged in. So let's actually finish the logout functionality. For example, in our admin panel, I'll search for the render icon, and below the render icon, we'll create a new arrow function called handle logout. It will be an async arrow function because we have to do some async operations with Firebase, and we'll incorporate this yet again in a try catch block. If we get an error, I console log it out. Otherwise, I'll await the sign out. Sign out. This is a Firebase function. And we pass in the current out object, which I hope got auto imported. Otherwise it will throw me error. There we go. It got imported. And then once we've logged out, I'll navigate. And actually we have to create that object once again. For example, below the card collection, const navigate equals use navigate. And then I call the navigate function or hook, and I pass in the /login once we are logged out. So let's refresh and try this out. Right now I'm logged in. If I log out, yes, and nothing happens because I didn't hook it up. So let's come and find the button, like the logout, there we go. On click, we are going to call the handle logout function, just like this. Let's test it out now. Logout, and I get redirected and logged out. But the logout is actually not seeable right now because we are not we are not root guarding, and that's what we are going to work on next. Okay, root guarding. For this I haven't provided anything to you. We'll be writing this component all together. I'll create the outroot.jsx file and then call refc over here. I hope you're familiar with this. I've showed this, or I've showcased this many times before on the channel. This is an extension. This will receive a prop called children because we are going to be wrapping roots in this. It will also use the navigate. So const navigate, this will be equal to the use navigate hook, just like we did before. This is how you redirect in React Router DOM. I'll be creating two other use states, which will be the is authenticated and the loading. And then this is going to be pretty simple. I'll copy paste this over. If we are loading, we return a div called or saying loading. Otherwise, if we are authenticated, we will render the children or null. That's it. So whatever is wrapped in this, we can only access if we are authenticated. Now, how do we handle authentication in Firebase? First of all, I'd like this check to run if we enter the component or the component render, so we'll be using the use effect hook. Always put an empty dependency array here before you waste your database calls. But actually, this time it's not going to be empty. We are going to pass in the navigate function because React Router DOM says that we should do this. So I'll go with that. And then we'll call the onOutStateChanged function. This is from Firebase. This is something that you can subscribe to. And if the out changes, then this will get called. Of course, you have to pass in which out are you looking for, because you can have multiple of those. So I pass in the out and then pass in an arrow function that will contain the user. Of course, if the user is valid. That's why we are going to check if user is not null, that means someone is logged in, then we'll set the isAuthenticated to be true. Otherwise, we'll set isAuthenticated to be false and we'll navigate the user to the login/login, just like this. And by the end of this, we'll say set loading to be false, because by default we are loading and we set the loading to false when this finishes. That's not enough because this will cause us memory leaks. So I create an unsubscribe function. This will be the function that the useEffect will return with, because remember, with whatever useEffect returns with will get called when the component unmounts, basically, and it will be the unsubscribe function, just like this. So if, for example, you navigate away from the login, that means the component gets unmounted, then you unsubscribe from the event, and then you won't have memory leaks in your app. That's it for this route, basically. It's pretty simple, pretty straightforward. Let's go back to our routes. And in our routes, all I'm going to do is at the admin panel, because that's what I don't want others to reach, I'll call the out route element and wrap it inside that, like this. There we have it. I'll delete this. And now let's see if this is working. So the login page can be accessed, that's great. Let me see if I can access the admin panel. And useState is not defined. Where did I not define useState? Yes, over here. I need to define useState. And there we go. I refresh the browser and let me show you this again. I get redirected to the admin panel because I'm not logged in. /admin and I get redirected. If I log in, then I can access the admin panel. I can then freely log out as well and I get redirected back to the login page. With this we are basically done. Maybe as an extra I will show you how to query, for example, at the dashboard. We'll be doing this by hand. You should probably implement a UI for this. Maybe you can take it as a task for yourself. So it fetches, but let's say I only want to fetch a few items. Let's have a look at this together. If you search for Firebase queries, you'll be able to find this site, and it's just like an SQL query would be. For example, you pass in var, and then between strings, capital, and then equals, this is also in strings, and then a value. Let's implement this together. In the query, I can pass in, for example, var from Firebase, and then inside that, power equals, and then 12. Also separate this with commas. Let's see if this works. If I come back to the app, nothing happened. Maybe I didn't have one with 12 power level, or, oh no, all right, now it fetches. The problem was that I didn't put it in strings. So if I put the 10 or the 12 in strings, then it now fetches. And now we always only get or only fetch elements that are with the power level of 10. And you can do this to the other fields as well. This is querying. One last thing I want to show you is how you can limit your searches. For example, you don't want to fetch all the parameters from here. If you click on order and limit data, you will be able to see that there is a limit function where you pass in a number, and then, for example, only 3 will be fetched. And also there is an order by function, and then it can order by, for example, the name. Let's actually do that. Let's order by the name. I delete the order or the var from here and order by, and I'd like to order by the title, and also limit them. And this will, I believe, ask us to create a custom query. So limit, and I'd like to limit this to be 2. Well, it doesn't ask us to create an indexed element. Sometimes in the console, Firebase will ask you to create custom queries, and then you just have to click their link and create it. It's pretty straightforward. It's getting ordered by the name and also displayed. What if I was to emit the limit, for example? So let's emit the limit. And now they really are in order. You can see it better like this. Let's say I want to order by power. I can actually do that. There you go. So if you were to provide a better UI for this, you could choose to fetch all the data and then query on the client side. or fetch only part of the data with querying from the database. It will depend on how much data you have in the database. Obviously, you have to leverage that and make sure you choose the right option. And as for the last thing I like to show you is that you can write rules. For example, I'd like to remove the time from here, and then if request.out not equals null, only then do we allow read and write functionality. Now this is a very basic way of looking at this, because obviously it can still be cracked if someone really wants it to, but this is usually what protects your database. I can then publish this and it should be working, because the last version was that everyone was able to read and write from your database, but now only those who have authentication, which is set up by yourself by hand, and they have to get your password and your email for that. Only those can write into your database. And you can do the same for the storage as well. If you come into rules, there we go. If you replaced it with if request.out, and I won't be going over all of these. If you need something very specific, it's probably worth your time, but usually you do not spend too much time when developing your app over here. If request.out not equals null, then we allow it to be manageable. Let's see if I can still get this. Yes, and actually I messed this up, because now we are missing sufficient permissions. So, but if I log in and now go back to the dashboard, I can then fetch. So what we've implemented right now is actually a mistake, but a really good way to showcase to you what this does. If you are not logged in, you cannot read the files, and that's something you want to separate. So you always want to allow read, but you only want to allow write if the request.out is not null. So this should probably be working. I've published this for the storage, and I'll do the same for the Firestore database. Go to rules, and the text is probably a little bit small for you people. Maybe this is better. Allow read always, but only allow write if request.out is not null. And then publish this, and let's see if I go to the admin page and then log out of this and go back to the dashboard, then I should be able to fetch the data. Just like this. I'm actually glad I messed this up, because I could show you more like this. So with this, our app is over. We can log in, manage this from the admin panel, log out. We have guarding. We are actually uploading to the storage and to the database. It's been a great journey to learn this. I found this helpful many times, so I hope you will too. Just don't go overboard with the free version of it, otherwise you might have to pay, but this is only the storage part. So with this, the video is over. I hope you enjoyed it and found value in it. If you did, please consider giving us a like and maybe even subscribe. Comment us down below what would you like to see next. And other than that, I hope to see you in the next one. Happy coding and God bless.